What's up, everybody? Welcome back to my channel. Here in this playlist, Quick Revision, I'll be uploading basic concepts of mathematics and science in which we have might learned earlier but couldn't grasp all at once. Just for a quick revision. Without further delay, let's proceed. Part 1. An introduction to the building blocks of matter. Today's lesson is about the world around us. It's about how we humans, as matter, study other forms of matter, including ourselves, since we are also matter. So, what have we learned earlier by definition? Matter is anything that we can touch, see, or measure. It has got mass and is something that occupies space. We call it matter. So here is a question. Is love, feeling like hatred, matter? We cannot see it or measure it directly. So is it matter? No, it is not a matter. What about air? We cannot see air. Is it matter? You might think the same, that it is not a matter. But actually, air is matter. Why? Because it occupies space and has mass. Therefore, anything we see around us, including us humans, even air, we are matter. And so now we are just scratching the surface of matter. And that leads us to the introduction to the building blocks of matter. Long ago, different philosophers tried to understand how matter is made of. They gave various theories to explain the composition of everything around us. For example, ancient Indian philosophers believed in 5 basic elements, like earth, water, fire, air, and space. That they believed that these together make up everything in the universe. Similarly, the Greek philosopher Democritus proposed that all matter is made of tiny, indivisible particles called atoms. He suggested that these atoms combine in different ways to form all the substances we see around us. To better understand this, imagine I keep cutting a piece of bread into smaller and smaller crumbs. Those tiny pieces, one by one, make up the whole bread. Similarly, you can think of little grains of sand or pieces of chalk. The idea is that if you keep dividing matter continuously, be it a bread, let's say, or if you break a piece of chalk, a point will come when it becomes so tiny that it cannot be divided any further. These indivisible particles were called atoms. It comes from the Greek word atomos. So that was when John Dalton proposed the atomic theory, explaining the nature of atoms in a scientific way and formulating laws about how atoms combined to form matter. But now, today, we know that atoms can be split into protons, neutrons, and electrons. But for a long time, they were considered indivisible. So now, these individual pieces of bread are what make bread taste like bread and not like sugar. The same reason why sugar is sweet and salt is salty graphite is soft while diamond is hard. It's because of how these individual atoms are arranged or combine themselves. These atoms determine the structure and properties of a substance. And this leads us to the concept of elements. We now understand that the atom is the smallest unit of matter that retains the properties of an element, just like a single crumb makes up part of the bread. So, what is an element? By definition, we know that an element is a pure substance that contains only one kind of atom. So, you are all familiar with the periodic table, which is basically a collection of all the known elements. For example, what makes gold truly gold? It is because gold is made up of only one type of atom, that is, the gold atom. But what about bronze? Is it an element? No, it is not, because it is actually a mixture made by two types of different elements, mainly copper and tin. So you'll have to remember this. If a substance has only one type of atom, we consider it an element. If it is made of a combination of atoms of different elements, that means it is not an element. Let's see. This is something interesting. Have you heard about CHNOPS? CHNOPS, which stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These six elements are actually the basic building blocks of life, and most of them are also among common in the universe around us. And what it is even interesting is that this idea connects with the Big Bang theory. We know that according to the theory, at the very beginning of the universe, light elements like hydrogen fused into helium, and later, in the course of the stars, heavier elements like iron and calcium were formed. And we are not surprised. Isn't it amazing that the same iron which flows in our blood, the calcium which strengthens our bones, the hydrogen and oxygen form the water in our bodies, these elements inside us are also the same as those scattered across the universe. I'll quote words from Carl Sagan and Neil Tyson, which they have said that we are all connected. We are made of stardust. Isn't it amazing that the elements which are present everywhere in the world around us is also present inside our human body? This shows that we are all connected and we all belong to the same stardust. So now back to the topic. So we have learned about elements. Now, what about molecules? By definition, a molecule is formed when two or more atoms bond together. When two or more atoms bond together. Note this. These atoms can be of the same element or of different elements. Same elements like oxygen gas, O2, made of two atoms of the same element, of the same oxygen element. Or it can be of two different atoms like hydrogen and oxygen combined together to form water, H2O. So this might create confusion with the compounds. Here's an important thing you need to see. So when we say molecule, it is formed by two or more atoms bond together. They can be of the same element or of different element. Same element like oxygen gas, O2, or different atoms element like H2O, water. So what about compounds? The important distinction is that a compound is a type of molecule It is a type of molecule. Compound is also a type of molecule where different elements combine together in a fixed ratio. So you see the difference that molecules might be of the same elements or different elements, and ratio might or might not be fixed. But compounds, it is a type of molecule where different elements combine together, but in a fixed ratio. For example, water, H2O. It should be always 2 atoms of hydrogen and 1 atom of oxygen. If there is any differences in the ratio, then it would not be water anymore. It would change the composition and structure and everything. And even NaCl is a compound, a salt. It has to be in that fixed ratio 1:1, 1 atom of sodium and 1 atom of chlorine. And this fixed proportion is what gives compound their unique properties. So note this. Any bonded atoms which belong to the same or different elements, that is a molecule, whereas compound, okay, it's like bonded atoms only, but then different elements, and it should be in fixed proportion. Therefore, we can say that all compounds are molecules because they are made of bonded atoms. All compounds are molecules. NaCl is a molecule, H2 is a molecule. But not all molecules are compounds. Why? Because some molecules like O2, N2, or H2, they contain only one type of element. Whereas in a compound, the bonded atoms should be not of the same element, but different elements. So that's the distinction. Now, next, mixtures. For a quick revision, let's go to mixture. By definition, a mixture is a physical combination of 2 or more substances where each substance retains its own properties. It's a physical combination, maybe 2 or more substances like air, but each substance which is present in that combination, it holds back its own properties. And unlike compounds, mixtures do not have a fixed ratio. And these components can be separated by physical methods, so maybe like filtration, evaporation, distillation, or even handpicking. Imagine soil to remove, maybe through sand sieve, to remove stone or heavier particles from soil, or even all these can be done physically, can be separated physically. So when we talk about mixture, we have 2 types, homogeneous mixture and heterogeneous mixture. Homogeneous mixture is a type of mixture which is uniform throughout. Components are not visible separately. For example, air is a homogeneous mixture. Salt dissolved in water. After stirring it, can you tell which one is salt, which one is water solvent? In that case, it is a homogeneous mixture. And in the case of homogeneous mixture, since it looks uniform throughout, you cannot separately, it is not visible separately. So you have to separate it by evaporation, distillation, chromatography, and those types. The second type is heterogeneous mixture. Here, the components, they remain separate, not uniform, like sand and water. You can, take it out by filtration, decantation, sedimentation, handpicking, sieving, centrifugation. So, in short, we can separate those by physical method and other methods as well. So, for today's introduction, that's all for the introduction for the building blocks of matter. We have learned about atoms, molecules, elements, compounds, and mixture. We understand that science, it is not just theory. It touches every part of life. Knowledge of matter, why we need to know the basic concepts of all this. Imagine not knowing sodium, and imagine someone puts sodium into water and it causes an explosion, or maybe pour water on electricity and risk death. So, science that goes beyond knowing matter helps us prevent accidents. It replaces myths like in medicines, how medicines are carefully prepared mixtures that cure diseases.